So, welcome everyone for this post-lunch session. We have our food. Now, let's go to water. So, the importance of dialysis water, the quality of that water cannot be overemphasized. One needs good water treatment system to achieve good quality dialysis and thereby good patient results. Whenever a new center is set up, the water treatment is often left to the technician or the vendor, and because nephrologist, he doesn't pay much attention to that water treatment, and over maybe next 3-4 months, the water quality comes down, and there is where the problems start. So as a nephrologist, we must know how to set up a water treatment, and I call upon Dr. Sagar Kulkarni, consultant nephrologist at KEM, to enlighten us for the setting up water treatment system. And I want more audience interaction after his talk is over. Sagar?
Hello. Okay. So in this session, we'll see some insights into setting up water treatment systems. The goal of water treatment is to dispense pure, sterile and pyrogen-free water to dialysis unit. It is achieved by pre-treatment of water followed by an reverse osmosis and then polishing of the treated water. So, we should design our system to satisfy clinical needs according to the raw water data we have to assure maximum safety and efficacy, which should be cost effective and depends on available skill set of human resources. So, you should know some physiochemical properties of your raw water. For example, extremes of temperature can affect performance of your RO membrane. High pH or alkaline pH can damage RO membranes. So in that case, we have to put an acid feed pump into the raw water to neutralize that high pH, which is usually seen in municipal water. High turbidity of water, especially in rainy seasons, necessitates frequent backwashing of sand filters. Similarly, if your water is very hard, you are getting very raw water is very hard, then it necessitates frequent recharging or regeneration and replacement of softener resins. So this is a sample raw water data in Pune, courtesy of Dr. Lobo, who provided this data. So you can note that the difference in hardness, calcium and magnesium levels of corporation water versus well water or dug well water or bore well water. And tanker water supply is the most unreliable source, and you don't know what will be the quality of raw water coming from tanker. And if you are getting a tanker water supply, then you should be ready for all the worst situations. You should anticipate all worst situations in the to tackle in your pretreatment. So this is the design of water treatment system of KEM Hospital, which includes a pretreatment, reverse osmosis, a storage tank, deionizer, followed by UV lamp and ultrafilters. Then water goes to dialysis machine stations. It comes back to the storage tank. So this loop of treated water coming back to storage tank is very important to improve the efficacy and to decrease the chance of contamination. So coming to the components of pretreatment. The raw water is pumped into the filters by raw water pump. These filters are bed filters and they work on principle of pressure gradient. So there should be pressure monitors installed before and after each of these filters. There should be a sampling port after softener to assess the hardness of water and performance of softener. Then there should be sampling port for chlorine after carbon filter to check for dechlorination. From here, water goes to reverse osmosis unit. So raw water pump should be a stainless steel centrifugal pump with capacity to match RO booster pump's feed flow, because this pump is going to pump water across the 4 or 5 filters, and then that water will go to the booster pump of RO. So the pressure is going to get dispensed over this filter. So this raw water pump capacity should match RO booster pump feed flow requirements. It should have auto switch mode to synchronize with booster pump of RO and float switch in the storage tank. We'll come to that later. And it should have manual mode also during the backwashing and cleaning process. This pump, it pumps the water through various medias filled in the pressure vessels. These pressure vessels are made of FRP, that is fiber reinforced plastic or stainless steel material, to bear the pressure of around 10 bar or 10 kg per centimeter square. The usual operating pressures are around 1.5 to 2 bar, and if the pressure goes very high, that is more than 10 bar, then it can burst the casing and can cause an accident. So the pressure should be monitored daily and meticulously to keep it in the operating range. These vessels are fitted with a multiport valve on the top, as you can see in these pictures, which can be operated either manually or they can be automated. These valves have multiple options that to keep in the action mode, backwash mode, or rinse mode. The volume of the vessel which you need for pretreatment depends upon the volume of media, that is how much sand, how much carbon, how much resins you are going to use. So this is the MultiGrade sand filters. These are the bed filters, as I said earlier. It removes particulate matter like dust, protozoas, then pollens, etc. from the raw water. It has a cutoff of 10 microns and its performance depends upon the pressure gradient. Too high pressure gradient indicates clogging of the filters, while too low pressure gradient indicates channeling in the filter. So both things should not happen, and if they are happening, then backwashing is necessary. In the picture you can see the various size of the sands. As I said, it is a multigrade sand. So below or the bed is formed by gravel, which is large gravel, and the higher you go, the sand particles go smaller in size. The heads are formed by the fine sand, and this fine sand is lost over the period of time and needs to be, when it is lost to the extent that it's not giving the appropriate performance, then we have to replace the sand in the filter. This is called as loss of heads actually. So carbon filter, in addition to dechlorination, it also removes pesticides and herbicides. It is a powdered activated carbon is very fine carbon particles, and there is rapid loss of heads, so it should not be used, and granular activated carbon should be used. The recommended iodine number should be more than 1000 milligram per gram. The wood granular activated carbon, which is cheaper available in the market, it has maximum iodine number of 900, so it should not be used. We should always ask our vendor to provide coconut shell granular activated carbon, which has an iodine number of around 1200, although it is costly. Another thing we have to look for is the flow rate of the water across the filter to assure empty bed clotting time of more than 5 minutes for each carbon filter. But the most important thing to monitor in a carbon filter is to check dechlorination status or dechlorination performance. It can be done by either chlorine strips, which are handy strips, and you can do it in the water treatment area, or it can be done by the online chlorine meter, which gives real-time chlorine concentration of treated water. The carbon filters should be regularly or daily backwashing and rinsing should be done. In addition, we have to check residual chlorine content at least once in a day. If the residual chlorine content after the worker carbon filter is more than 0.1 ppm, then we have to backwash and rinse the filter. If this problem persists even after doing backwash multiple times, it indicates that carbons have exhausted and we have to replace that carbon. We should also monitor the pressure drop. As I already said, it should be recorded daily. If there is any rise or fall in pressure drop more than 30% of the baseline, then we have to do backwash to treat the clogging or channeling in the filter. The softener. Softener protects RO membrane from fouling by calcium and magnesium salts. The capacity of softener resins is determined by grains they can absorb in per cubic feet. So higher the capacity of adsorption, better the quality of softener resins. To keep this quality intact, we have to do periodic regeneration of the softeners. And softener malfunction can be a counterproductive, as we experience series of patients getting admitted with hypermagnesemia from a single center, because on investigation we found that softener was not regenerated and was not working properly, and we got a epidemic of hypermagnesemia from that center. So this should not happen. Although we are regenerating it regularly, we should also look for the performance by checking hardness. If the hardness of water after softener is more than 17, then we have to do backwashing, rinsing and regeneration again. So how to regenerate softener resins? We need 6.8 kilograms of salt per cubic feet of resin volume we have used in the softener vessel. This much salt is to be diluted in water at concentration of 8 to 12%. Now this solution is called as brine solution. This brine solution is sucked and poured into the softener resins by multiport valve. This brine solution should be kept in contact with softener resins for 30 minutes and should be followed by a rinse. After regeneration process, we should again check for the hardness, and that should be less than 5 ppm, which assures that adequate regeneration has happened. This is the picture of multiport valve, which shows this is the inlet, this is the outlet to the next filter, and this one is going to the drain. And you can see this inlet is for the brine solution. So this is the multiport valve for softener. Now we will come to reverse osmosis unit. It includes a booster pump, a 5 micron cartridge filters, antiscalant dosing and RO membranes. So booster pump for RO, again it should be a stainless steel pump and not a cast iron pump. At cast iron can get corroded by the chemicals we use for disinfection, and it has very less hydraulic efficacy compared to the stainless steel pump. So although cast iron pumps are cheap, they should not be used. The capacity of the booster pump depends upon the RO capacity and output of water you need. Then comes pre-RO cartridge filters. These are made of polypropylene material, and they are placed before RO membranes, and with a membrane cutoff of 5 micron filters. They filter out other suspended matters, carbon fines which are coming from the filter, and protect the RO membranes and improve their life. They should be inspected regularly. Ideally every weekly they should be inspected, and if they become brown and black like this, then they should be replaced. Scaling of RO membrane is another problem which decreases the performance of RO. Therefore, antiscalants are acidic compounds which prevent crystallization and precipitation of these salts over the RO membrane. So these compounds are continuously fed to the RO inlet via a dosimeter, which is placed prior to RO membrane. Now coming to the RO membranes. These are very expensive, and therefore we should select them very wisely, and we have to take care of the RO membranes by assuring proper pH, temperature, chlorine content, scaling and colonization. This picture shows the membrane characteristics of various filters. So as you can see at the top, there is a microfiltration that, as we saw, the 5 micron filter. It can remove suspended solids and few bacteria, but cannot remove viruses and ions. Ultrafiltration, that is submicron filters, they can remove suspended solids, bacteria, viruses and endotoxins, but they cannot remove ions. And unless and until we remove these ions, they cannot remove ions. So unless and until we remove these ions, water cannot be pure. So RO, reverse osmosis, removes all monovalent and multivalent ions along with viruses, bacteria and suspended solids. So this is the importance of having RO membrane. These membranes are thin film composite membranes with an active membrane surface of polyamide, which has a thickness of 2500 angstrom, that is just 2.5 nanometers, and a membrane support sheet of polysulfone, which is 50 microns thick, and a membrane separator which made of dacron. There is high pressure applied to one side, and from other side permeate comes out through a central channel. So this sheet of membrane is rolled to form a cylinder, and they are put in the vessel. of again made of FRP, that is fiber reinforced plastic, or stainless steel. The capacity of the RO depends upon the number of membranes and number of tubes you are placing in series or parallel. The desired output of RO membrane depends upon the number of stations and method of feed you are going to use, that is indirect feed or direct feed. For example, if you have a RO with storage tank, and 750 liters per hour RO can fill the storage tank up to 1000 liters, 1000 liter in 80 minutes. If you have same storage tank but 500 LPH RO, then it will take 20 minutes more to fill. So that is the only difference with the capacity of RO. It doesn't mean that high capacity of RO means high quality of water. It just describes the time it takes to produce that much amount of water. And one machine needs around 30 to 40 liters of water per hour at specified pressure. So direct feed, we should assure that this specified pressure is maintained throughout the piping system. Coming to the distribution system, it can be a direct feed system or indirect feed system. In direct feed system, the reverse osmosis permeate directly goes to the piping and distributes water to machines. While in the indirect system, the water first goes to the storage tank, and then from storage tank it is supplied to the all stations and then comes back to the storage tank. This is called as loop, as I showed you in the previous picture. So direct feed can supply limited number of stations, and it has to maintain that pressure across the length of piping. But indirect feed, as it uses a separate pump, it can use for longer distribution system. Here water wastage is very high because it is not a loop system. Here water wastage is less. But the advantage of direct feed that you don't have to store water, so likelihood of bacterial contamination and growth is less. While indirect feed, there is chance of contamination, but if you do proper meticulous disinfection, regular disinfection of tank, this chance can be reduced. What is double pass RO versus two-stage RO? So you should not get confused if your vendor asks you such questions. So double pass RO means that permeate water goes to second RO, which purifies water further. So you can get more purified water by double pass RO. But there is more water wastage. As you can see, the raw water will be filtered. Some 50% of water will come as permeate. This 50% will go to another RO, and again 50% will be removed or rejected. So you will get only 25% of the water output. But in second stage RO, two-stage RO, the reject water goes to second RO. And this reject water is again filtered, and out of that permeate water is recovered. So there is less water wastage. And the further polishing, that is more purification what we need, can be achieved by introducing a deionizer in the system. So RO membrane needs monitoring again by pressure and flow monitoring. So the pressure, there should be less than 30% change in the pressure as you have to monitor in the dials, and flow meters are installed in the RO panel. The conductivity reduction across the RO should be more than 90%, and microbiological purity should be assured by doing cultures once in a month. So coming to storage tank. Storage tank should be made of 316 stainless steel or medical grade PVC. It should be a cylinder with conical bottom. The outlet of storage tank should always be at the conical end, and inlet should be at the top. The lid should be airtight, and water level should be monitored by a side tube method and a float switch. The outer connection, the outlet, is connected to a transfer pump and a drain pump, both. And the capacity of the storage tank depends on number of stations, and usually for one session you need 150 liters of water, including the disinfection and all of machine. So number of stations you want to run and number of machines you have decides the capacity of storage tank you need. So how will you know that your tank is full? You are not supposed to peep inside the tank. So that there should be a float switch installed which turns off RO and raw water pump automatically when the tank is full. So this is, you can see this is the float switch. If that goes up, it will switch off the pump. When the water level goes down, it will automatically switch on the pump. In addition, to look for real-time water level outside the tank, you can install a tube which will show you how much tank is full. Then from water goes via transfer pump to the stations. This transfer pump, again, it should be a stainless steel material, and it should have capacity to give a flow of 0.9 meter per second throughout the piping system, and should give a minimum pressure at machine inlet of 1.5 bar. Then further polishing of water is done by deionizer to give a pure water. Pure water has zero conductivity. As you can see, this is the conductivity meter which is kept online, and it is showing zero conductivity. So this means the water is pure, that is without any ions, without any other impurities. It is just H2O. So deionizers are of two types. It can be an electro deionizer or resin based deionizers. A resin based deionizers basically has two resins, alkali resins and acid resins. It can be separate, that acid and alkali resins are separate, or they can be mixed. The mixed bed resins are difficult for maintenance, so two bed resins are preferred modality. So these resin based deionizers, they use hazardous chemicals, as these resins has to be recharged regularly. That is hydrochloric acid and sodium hydroxide is used for recharging, and we need a trained personnel to handle these hazardous chemicals. But it is cheaper for operation, cheaper for installation. And electrodeonizer, it does not require any hazardous medicine, and it is simple to operate, but it is expensive for installation. The resins of DI needs regular recharging with hydrochloric acid and sodium hydroxide once or twice a week. The electro DI recharging is done by changing the polarity of electrodes. So while working, these electrodes, they take up chlorine and sodium from the water in negative and positive electrodes respectively. And when we are recharging them, just we have to change the polarity of electrodes. So whatever chlorine and sodium they have taken up, they will be spent in the water now. And this water after recharging should be drained off. So that's how recharging of the electro DI is done. If deionizer is not recharged, then it can lead to catastrophic consequences. Therefore, if we are using a deionizer in our plant, we must look after it, and it should be recharged regularly, as it can release large amounts of sodium and chloride in the treated water, and it will directly go to the machine without any further filtration. So we have a UV light disinfection also installed, as we have storage tank. So if at all any contamination is happening, we want to disinfect that water. So short wave UV light dissociates DNA and kills bacteria. But the problem with UV light is it releases the endotoxins. So it must be followed by endotoxin filter of 0.2 micron cutoff. The 200 to 300 nanometer germicidal wavelength should be there in your UV system to achieve the optimum radiation dose of 16 millijoules per centimeter square. And if we are using a UV lamp, then it should be covered with a stainless steel cylinder, as the PEX can get damaged by continuous exposure to UV. It is followed by the submicron filter, as it is the last filter of the water treatment system to take care of the endotoxins which might be generated by killing of bacteria. The pressure monitoring is must at this point to ensure adequate pressure at machine inlet, and this should be replaced every 3 to 6 months, or SOS whenever there is crop of infections. So distribution system, that is the piping, it should sufficient to supply all stations, reprocessing area and concentrate mixers. It should be made up of 316 stainless steel, PEX or medical grade PVC. But if you are using PEX piping, then we should take care that it should not be exposed to direct sunlight. As I told, PEX get damaged by ultraviolet rays. And stainless steel if you are using, then we should not use bleach for disinfection. The design of distribution system is a challenging task, as we have to minimize bends, we have to avoid blind branches and blind ends. So for that, we should ensure that the piping gets looped to the storage tank. So there is a Yoga Sutra which says Heyam Dukkham Anagatam, which means the pain which is yet to come is to be avoided. And when you get a infection in your water treatment system, then or biofilm in the water treatment system, then it is a pain. So we can be avoided by regular cleaning and disinfection. But as we are short of time, so this cleaning and disinfection part we'll discuss in tomorrow's workstation. Okay, so I will skip to the last slides. These are 4-5 slides we'll discuss tomorrow in the workstations. So next, as it has been discussed already, whenever we have installed the water treatment plant, all the specifications of material, pumps, whatever filters, RO membranes we have used, these specifications should be documented and it should be kept in a file. The standard of procedures for disinfection and maintenance of the tank should be printed and kept in unit for ready reference of technicians or whoever looking after unit in your absence. The logs of all parameters, events and actions, as Sir told in his talk also, any event, any obscure event happening in the unit should be recorded and it should be periodically reviewed by a nephrologist. So, setting up water treatment system, you should understand your requirements, what fit for your area, your patients. You should spend wisely and to avoid extravagant expenses. And you should monitor that plant vigilantly. Even if you install any best plant, if you are not monitoring it, it will not work properly. And you should not compromise with water quality, do not cut corners, and do not let in technicians' hand completely. So investing in water quality will improve outcomes of your patients, their quality of life, and your career also. Thank you.
Thank you, Saga. Any questions? So I have some questions for Sagar. Do we need RO and DI both? Yeah, sorry. Yeah. Do we need RO and DI both, or one can suffice?
No, as I told, RO has a capacity to reduce or purify water by 90%. So if we say that the TDS of the incoming water is 100, then RO can reduce it to 10, but it cannot make it 0. Even if you do double pass RO, then that from 10 it will come down to 1, but again it will not become 0. So deionizer is a must, as it reduces the water, it produces the purest water it can.
I think deionizer is a must, otherwise you will have more load on the RO membrane and it will be destroyed earlier. Yes. So the life quality of the RO membrane will decide on your deionizer. Yes. And if there is a groundwater where your hardness is high, then you can have a 3 cathode, anode and mixed bed. So that will reduce your load on the RO system. And you said the chlorine, if it is there, you need to change the carbon. If there is a carbon fumes, then what to do? There is a carbon fumes. So earlier people used to say the carbon. Fines.
So the fines are caught by the submicron
filter.
That is why those
black
filter
5 micron filters which are installed here.
The black filter picture which he showed is because of fine sand and carbon getting caught in it.
So then that is the time to change it also?
So that is where monitoring comes in. Your carbon tank has a finite volume of carbon, and Sagar showed that your empty bed contact time is 13. The volume of the carbon in the tank divided by the flow of water, which is again a volume. So if that empty bed contact time falls below 5 minutes is what they recommend. Chloramines you have to have 5 minutes. Free chlorine you will get away with a smaller amount. When the chlorine residual chlorine starts leaking into the water beyond the carbon tank, that is the time to change it. That is probably because the volume of carbon has fallen in the tank. So you don't need to open the tank. When you see that chlorine is leaking out beyond, then that is the stage at which the carbon volume has fallen and it's not doing its job. Or if you increase the capacity of your raw water pump so that suddenly your flow volume, the flow of water has increased, then your empty bed contact time is going to fall because the flow is in the denominator. And what is another point is that you have to don't measure the residual chlorine if you don't have online. Sagar showed what we have, which is an online measurement. So this is continuously reading out 24 hours a day, and it can be linked to give an alarm, bypass the water, or switch on lights in the unit, etc., various things. But if you don't have this, then don't do your measurement of chlorine first thing in the morning when you start the unit. Because the water that has been standing in the carbon tank will have 0 chlorine. But as you start running it, that's when the empty bed contact time comes in, when there is flowing water over the carbon. So it should be measured 15 minutes to half an hour after starting the plant and not after an overnight stand of water.
But if you're using a groundwater, you don't require a carbon at all.
If you're using groundwater, you may not have chlorine, but you could still have pesticides and herbicides, as he said, which are organochlorine compounds very often.
If you have water shortage in a city, what is the best way to design an RO to reduce the waste?
So we have to depend on the tanker supply then.
No, he said to
Which
RO.
Save water.
Save water.
Save water.
Ready soften.
Whether you just thought if you put 2 ROs in a series, you will
Yeah.
be able to
That's not practical when you have a water shortage. So,
loop going back and
yeah.
But
Yeah, so the reject from a second RO can be fed as a
Yeah.
feed water because that is already purified
two-stage RO
water.
we can use to
so you can do
use
that.
the reject water again. Two-stage RO can be used to utilize the reject water.
Reject. No, even if you have 2 double pass, the reject from the second RO can be fed
Can
back
be
as
again
feed
fed
water
back, yeah, making
into
the
the
loop again.
system. So we have done that in the past. And the second thing is deionizers. Deionizers are fantastic with one reservation. When we are talking about purity from deionizers, it is mineralogical purity. Deionizer resins have been said that they are a good medium for bacteria. Now we have never in 17 years had bacterial growth from our deionizer because we use 10 normal hydrochloric acid and 10 normal sodium hydroxide twice a week to regenerate it. If you can do that, the deionizer 10 normal hydrochloric acid will dissolve anything. 10 normal sodium hydroxide will dissolve anything. No bacteria, no virus, nothing is going to survive it. But if you forget to do that, you will 100% have a growth of bacteria in the DNA. No, in addition.
And Dr. Sagar mentioned actually that it should be designed to the worst quality of water that you are going to get in the year. So preferably in monsoons. Pritam?
Sir, you mentioned that deionizer once or twice a week should be recharged. Will it depend on the how much dialysis sessions we are?
Actually, you can monitor conductivity online, and if your conductivity is going beyond the limit, then you should recharge even if it is not due.
So beyond limit means above 10 or
No,
1?
it's 1.
1.
Maximum 1 is it can be permissible here and there. Ideally, it should be 0, but 1 is permissible. If it is going beyond 1, then you should recharge them.
Okay, but if after 1 week also it is not going above 1, so
Then it may go next day 1. So we can, as I said, we have to prevent the problem rather than treating it. So ideally, it should be done every week.
I was asking same thing. I was also asking the same thing. Electronic deionizer, how frequently it is supposed to recharge?
Yeah. So I think same answer applies for electrodialysis.
Electronic deionizers are called self-regenerating. So you can program them so that they will regenerate after a certain number of hours. So you don't have to do that manually. Because you don't need chemicals, you don't need anything. As he said, all that happens is that the valve which normally taking the product water will close and a drain valve will open and the polarity will be reversed. And that will drain all that water rich in ions down to the drain. So you can program it for a fixed period of time. Electrodeionizers are costly. They cost about 3 lakhs. Yeah, so that will depend. You'll have to study your water. Pritam's question was very valid. What is the quality of the water and what is the amount of water you are using will determine how fast your system, any sort of ion exchange system, gives up. Membrane filters are not so dependent upon the quality, upon the volume used. But any adsorptive filter, whether it's a deionizer, whether it's a softener, whether it's carbon, where it's adsorbing something, it has a finite capacity to adsorb. So these are the things where the frequency will be determined by the load that you give that.
Any further questions? Okay. Thank you, Sagar.
If you are using for the pipes, it has to be stainless steel.
Okay, so we'll move on to the next session.